Okay, let's get started. Hello, everyone. Welcome to Infant Store's latest live webinar, Enterprise MLflow with Sagemaker. Today's event will showcase the excellent integration between Amazon Sagemaker and MLflow, also known as the world's best open source ML platform. There will also be a Q&A session at the end, along with more information about our company and the Yeti Tumbler giveaway. So thank you for joining us, and please welcome Infant Store CEO Jagin.
Thank you, Aditya. Thank you all for attending our webinar, Enterprise MLflow with Sagemaker. Let me start with a brief introduction to ourselves. My name is Jagin Sundar. We're big data analytics folks. I used to be the CTO of Vandisco. I was co-founder of a company called AltoScale, and I worked in the HDFS group at Yahoo prior to that, which is where I actually met my co-founder Jitendra, who was leading the Ozone and HDFS efforts at Cloudera. Got a lot of experience with distributed computing and quite the expert in all things distributed and storage. We also have a gentleman named Raj who runs our India division. So today's topic is Enterprise MLflow with Sagemaker. Little bit of a definition. MLflow is both an open source project and it's supported in a supported and developed and enterprise grade product by several companies, of which we are one. There are certain capabilities that are mostly available only in the enterprise versions of MLflow. We'll talk about those. We'll also talk about what's available in open source, which is a very useful piece of software. And finally, Sagemaker is Amazon's suite of tools for machine learning. It's an outstanding suite of tools, and its integration with MLflow is a particular topic of discussion today. Towards the second half of this presentation, we will go through the complete process of taking a Hugging Face sentiment analysis model, logging it as an artifact to an MLflow instance, our own free version, in fact, and then using that as a model that is to be deployed in Amazon SageMaker. Now, this is a complex set of tasks, and the amount of functionality and the amount of capability that you get in the system is quite astounding, but it's all possible by means of a few commands typed into both MLflow and SageMaker, and it's a wonderful state of affairs. So we'll go take a look at that. So what is MLflow? It's basically MLflow with some enhancements for enterprise requirements. The enhancements include authentication, so users can actually log in using either the corporate identity or a separate user database. Authorization, so people can be authorized, logged in users can be authorized to view, read, maybe edit, experiments, and models. Audit capability, which brings the ability to make sure that all data science activities are actually recorded. That can be made compulsory if necessary. Scalability, when you roll this out to an enterprise, you need to ensure that any number of users can be brought on board, all the way from 1 or 2 data scientists to hundreds of data scientists. High availability. If the system goes down, all of your data scientists are essentially unable to do their work. That could be a very big problem. So this needs to be highly available. Finally, disaster recovery. Disaster recovery refers to an entire region going down. Because I hit the wrong button. An entire region going down, you need to be able to bring the service up in another region in a timely fashion so work can continue uninterrupted. So what is SageMaker? As I mentioned, it's a rich suite of tools from Amazon for the ML purpose. On the front-end side, for data scientists, they have the studio and notebook instances. Model deployment is very well fleshed out in SageMaker. As you can imagine, the cloud started with EC2 instances from Amazon. That was the genesis of the cloud as we know it. So it's no surprise that model deployment using Amazon SageMaker into VMs and containers inside VMs is very, very well thought out and really nicely done. Model monitoring, etc., are also capabilities that are available in SageMaker, although we won't be looking at that particular capability today. So I wanted to say this before we go ahead, right? There are many ways to monitor and track experiments and models, but MLflow has quickly become the leader in this space. And there's a reason for that. We are truly standing on the shoulders of giants. The folks who invented this first were very thoughtful. The folks from Databricks and Azure Machine Learning who built it out first were very thoughtful. Contributions from SageMaker are outstanding. Contributions from the PyTorch folks and the TensorFlow folks and Keras and others have made this easily the best platform to track experiments and models. And you'll see one reason why. The demo later in this webinar is going to prove that. The awards are, of course, out there. InfoWorld Bossy Award was awarded to MLflow, and the Kaggle survey resulted in MLflow being the second most popular tracking system, even though it's only 3 years old or so. So what are the capabilities that MLflow really excels at? Experiment tracking. Deep learning, as we all know, is an iterative process. Experiment tracking applies some structure and helps data scientists and the enterprise also. It is the direct analog to lab notebooks from the old days or even current chemistry experiments. If you have the need to, for example, a drug company applying for FDA approvals would not think of doing so without lab notebooks. Similarly, a machine learning based drug discovery process needs a log of experiments made, and experiment tracking for machine learning is best done using MLflow. There are also regulatory reasons why you may want to prove that you used certain data for certain experiments to produce a model and thereby prove that you did not intend harm or bias of any kind. Again, experiment tracking is critical for that. Model management. The model is an interesting entity. It's both binary bits, weights, and things like that, and code. And it needs to be versioned, tracked, move to production, move to staging, archive it, things of that sort, roll it back, put back an older version into production because the new one is erroneous in some way. These are not things that are solved by Git. And the capabilities of model management are also different from Git. For example, branching and merging are not really constructs that are useful here. So model management needs a special purpose tool, and that's what MLflow brings to the table. So if you take a quick look at experiment tracking, it's useful for both data scientists and data engineers. Data scientists can set up to log all runs. We have enhancements that provide this capability. Data engineers can track and schedule the scheduled automated runs. Maybe you have a model that you're running some inference on every day or once a day that involves some level of pre-processing. So you build a pipeline, you run the pipeline every day. If something goes wrong, you want to go back and look at it. It is also considered part of experiment tracking. And this is a very useful capability. We'll take a look at the experiment tracking user interface later on, but this is a screen capture of that particular capability. What are the enterprise features that most enterprise MLflow offerings add in addition to what's available in open source? The open source version is a useful single user tool, and to really make it an enterprise-wide capability, you need to add the ability to share experiments. Now, sharing experiments, of course, implies that you need to know who's logged in and what they're allowed to do. So authentication is paramount. Our system enables you to authenticate either to your own corporate directory or use a separate directory of users for MLflow. And the authentication is smooth using OAuth 2, so single sign-on is automatically included in the system. Authorization is an interesting capability. Now, when you have formal structure around machine learning and you have a large team and you're spending a lot of money, and some of these things are, you're looking at millions of dollars in expense, you need to be able to say that certain number of experiments are authorized in specific manners. The roles that we chose in our system are reader, editor, and manager roles, and you can apply any of these roles to any particular experiment or model. That's the granularity. So runs inside an experiment inherit permissions from the experiment authorization, and model versions inherit permissions from the model itself. And the three roles, as I mentioned, are reader, editor, and manager roles. Now, model management is, as I mentioned, a critical functionality that's different from Git-based management of versions. This is basically tuned for models for machine learning. And nowadays models can be quite large. You have 20 gigabyte GPT-3 or Eleuthera models, and those need to be managed in a different way from other entities. You need to be able to set specific versions of the model in staging, production, or archived states. You need to be able to transition models between stages, roll back, maybe put an older model that was archived back into production. Those sort of activities are possible with MLflow model management. What are the enterprise additions to open source MLflow model management? Again, model sharing between team members, between groups. The notion of sharing is essentially invalid without authentication, of course. So you authenticate using your corporate Active Directory or Google OAuth or Auth0 or any authentication system. You have a set of groups assigned, and you can offer permissions to the models. Those can be reader, editor, or manager roles again. And as I mentioned earlier, every version of a model inherits its permissions from the model itself, and that we will see in just a bit in the demo. So let's dive straight in. The point of this this webinar was to be hands-on, and I've chosen two specific activities to demonstrate here. One, and both of these are available in open source and available described in more detail in a Medium article that I've written. But the first one is interesting in that Hugging Face has tried to make things easier in the NLP world by building out pipelines of tasks. And one of those tasks is a sentiment analysis task. So you go out and you initiate this pipeline. It downloads a model from Hugging Face, and you can use it. We have made it a little bit more useful by logging that model as an artifact in MLflow, so you can version it, track it. You can, if you fine tune it later on, you can manage the fine tuned capability as well, that sort of thing. So let's go to the first. Some of this is going to be recordings on account of the fact that these tasks take a lot of time sometimes. So this is the source tree up on GitHub, and it's called Hugging Face Sentiment Analysis to MLflow. It's in the Instance Store repository. We will send out links to this. I am going to copy the location of this particular model, and I will go and some of these activities I'm demonstrating on command line, but you can actually use Jupyter Labs cell to run all of these. I'm cloning the repository, and next I'm going into the clone repository, and it's a simple command. I'm going to say python logmodel.py, and it's going to go through, and this is the point where it actually downloads the model from Hugging Face and logs it as an artifact to MLflow. You can see that Infant Store MLflow plugin is logging in. This is the authentication we've added to the system. So I'm actually logged in as an authenticated user. So Hugging Face is now saying no model was supplied, defaulted to Distribute, base, uncased, fine-tuned SST2 English. Now, I will admit I'm a beginning data scientist, and many of you folks may know more about these things, but some of these models are quite amazing, actually. I am so wowed by how accurate they are in the tasks that they're set out to do. So as you can see, it's now downloading the model, then it's going to push the model into MLflow. So our MLflow uses Amazon Lambdas and DynamoDB as service. It doesn't use MySQL or anything like that. And it's fantastically scalable. We tested to over 1,500 users. It also uses S3 as storage, which means that what's happening now is that the model got downloaded from Hugging Face into my local laptop, and it's now being pushed into S3 as a model artifact. You can also see a log here saying found credentials. This is photo, it's an Amazon library log saying found credentials and tilde/.aws/credentials. This implies that you need to have bucket access permissions for every user. Now, this is one mode of operation. In our infant store MLflow, we have an enhanced capability that we've recently added. And that's an artifact plugin where you can specify at the time of software configuration that don't assign AWS credentials, use pre-signed URLs. In that case, you don't need to create an AWS account for every data scientist in the company. Okay, that finished. Now this is now being logged as a model in MLflow. Let's go take a look at the model, and here we go. So I logged it to an experiment text expert 2, so I'm going to click on that. And a few minutes ago, I started that. If I click on that run, I can see that the model has been uploaded. Now it is logged as an artifact, and you can see there is a register model button. I'm going to choose a specific model, sentiment analysis. Model will be registered as a new version of sentiment analysis. I go ahead and register that. And now let's go look at the models page. You'll see that sentiment analysis has a new version. You can do the versioning that I mentioned. You can take this new version and put it in production, for example. So I'm going to transition into production. And once we go back, we will see that the model is now, that version of the model is now in production. And up top on the right, you can see that I am actually logged in as a user. Now, one thing that you have to do before we attempt, I mean, it's pretty ambitious to try and take this model from Hugging Face and deploy it on Amazon Sagemaker. What I like to do is, stage it. And the next step that I like to do is to test that the model that we just uploaded actually works by deploying it in the local laptop. I'm just going to run it so that it runs my local laptop. The run ID, which was created, I copied that. And if you see, I'm running a command, MLflow models serve-m runs : run ID / model. Again, photocore found credentials, so it's downloading the model bits from S3. And as I mentioned, if you choose to use infant store MLflow, we have capability to do artifact plugin that doesn't need S3 permissions for this. So you can manage it using your MLflow permissions itself. So now the model has started. I'm going to run an invocation. And what I'm doing here is using curl to post to 127.0.0.1 5000. That's my local machine. And the text that I sent is in format split JSON. And I sent 2 lines. This is lousy weather. And second line, this is great weather to the invocations endpoint. And I got, this is lousy weather, labels negative, score is 0.999. It's very certain, the model's very certain. The model is just fantastic, by the way. Kudos to the folks at Hugging Face for putting that together. But the next one, of course, this is great weather, labels positive, and score is 0.999. Now, this is running in my local machine. The next step, of course, is to deploy the model in Amazon SageMaker. What does it take to deploy this model in SageMaker? We need a few resources in Amazon. we need a suitable container in Amazon AWS ECR, Elastic Container Repository. Now, the way this works is SageMaker creates a virtual machine and it runs the suitable container that is created in that virtual machine. There's a one-to-one relationship here. I do not believe that Amazon uses Fargate or other container management systems or Kubernetes or other container management systems. I think they use a full VM for that container, and the only thing they get out of using the container is this prepackaged environment that's guaranteed to work with MLflow. We, in fact, if there are Amazon folks in the webinar, and if there's something wrong I'm saying, please do correct me. But we also love this idea of having a full VM for the container, because these models and inferences are sometimes pretty heavy duty, whether it's memory or CPU or GPU resources. There is very little to be gained by splitting up a VM into multiple containers for this. So we also use a single container per VM oftentimes. The next thing that you need in the system is an S3 bucket. It's a scratch bucket. Basically, Amazon SageMaker's client, AWS client, will tar up the model bits. Just like I showed you right now, we download the model artifacts from S3 to the local machine. We'll tar it up, stuff it in S3, and then give the command to the SageMaker backend to go ahead and create a particular container in a particular VM and run the inference code there. So for that, you need a scratch bucket. Finally, you need an execution role for SageMaker. Now, Amazon has a very sophisticated permissions model. And one of the things that it does is Amazon services cannot willy-nilly access your resources. They have a fantastic way of organizing it such that you create roles giving very specific permissions to Amazon services to access your resources. And that's exactly what this is. This is a role for the SageMaker backend to take and access your resources, and you're permitting it to do exactly what you want it to do. Okay, let's go back to our screen captures and look at the next one. The next step is we're creating on my local machine, we are creating a container that's suitable, and we are stuffing it up in Elastic Container Registry. A couple of things you'll notice, this is running on the command line in a Linux node. You could, my desktop is a Linux desktop. You could do this on a Docker capable Macintosh as well. Docker capable Windows, it has been known to work, but there may be challenges there. And one possibility is to just spin up a VM. This is a one-time thing. Every time there's a new release of MLflow, you need to do this once. This is doing it for version 123.0 of MLflow. And if you're having difficulty, if any of the attendees here, you're having difficulty doing this particular action, shoot me an email and I'll put together an AMI up in the cloud so you can just create a VM from that. Run this task, it'll stuff the container into Elastic Container Registry, and you don't need that VM after that. You can just terminate it and be done. That's sometimes easier than fiddling with Docker on your laptop or your Windows, or sometimes the cloud is useful in surprising ways. So here what we are seeing is a number of Python packages are being downloaded and the container is being created. And the actual layering of stuff, as it turns out, is a virtual machine. You will specify the type of virtual machine in the next command that we're going to look at. A container, this is the container that's being created. And in the container, the particular model that you logged has a conda YAML specifying what type of conda environment it should have. The conda environment is created and then it's run. My experience has been that when there are Python packages that depend on native libraries of some kind, it's better to put them in the Docker file and make them part of the container and not handle it in Conda. Conda has some challenges doing that. And so this is a ideal combination. Again, as I mentioned earlier, what I'm particularly impressed by is this is a complex set of activities between MLflow, our enterprise capabilities in MLflow, and SageMaker. I mean, the SageMaker integration makes this all very, very easy to do. This is a lot of work has gone in. So kudos to the folks at Amazon for doing that. Okay, now you're going to watch paint dry. Basically, upload on this. It's going to take some time. So let me fast forward a little bit, and pushing 840 megabytes. That's the size of the container. Should take a few more seconds. Let me actually fast forward a little bit more. And a little bit more got done, and there we go. So now the container is pushed, and finally, if you do a Docker images on your local machine, you can actually see that there is a particular container that got pushed to the SageMaker environment, Elastic Container repository, and it's called for SageMaker deployment. So let me kill this and show you what it looks like in the Amazon console. I go to AWS, I log in, and then I'm starting Elastic Container Repository, which is actually part of Elastic Container Service. And once I click on the repositories here, you will see the for SageMaker deployment. And when I click on the for SageMaker deployment repository, you'll see a particular version. The tag is 123.0. As I mentioned, a new version of MLflow, you need to run this again and get a new tag. And you'll be specifying this tag when you do the actual deployment of the model. Let's go take a look at the deployment of the model, which is, I need to show you how to create before we deploy, we need to create a bucket. This is pretty straightforward, but again, click on S3, go in, and I'm going to create a bucket. I think I'm just going to do chickens, SageMaker Scratch. My habit is to add the Scratch part to the name, so sometime later I can delete it without worrying too much about the content. Here we go. I click on create bucket, and that's going to result in the Scratch bucket being created. And let's go to the next screen capture. This is an interesting piece. This is something that you may want to pay attention to. This is where we're creating the role for the SageMaker service to take and use our resources. I click on IAM, and I'm going to click on the roles, create roles. And in here, I'm going to say AWS service. The role is for an AWS service, and use cases for other services. I'll click on SageMaker. This is the new role IAM API user interface, which I quite like actually. It's a little bit more intuitive. I click on SageMaker execution, allow SageMaker notebook instances, training jobs, and models to access S3, ECR, and CloudWatch on your behalf. Click on next. Now, if you see the permissions, it'll show you Amazon SageMaker full access. Click on next, and I will go ahead and give it a name, role for MLflow SageMaker deploy, and click on role, create role. Take a few minutes, and I should have the role created. Okay, now let's go and look at the actual deployment of the model. So here's the command. I've got it pre-typed in, and it has specific parameters. App name is Xformer. We'll be using this in the inference end. And model is defined by the runs. Remember the same run number, run ID that we used, that one. The execution role is the role that we just created, the ARN of that role, Amazon resource name of that role. The bucket is again Scratch, SageMaker Scratch bucket, which we just created. Image URL is, so this is the container that we created in the first step. And you can see the 1.23.0 version. region is US East 1, and mode is create, and instance is ml.m5.large. You need an ML type instance. It will not work if you specify a regular t3.large or anything like that. Instance count is 1, and the flavor is Python function. I hit return, and InfinStore plugin is logging me in. So this is all authenticated. It's logging me into InfinStore MLflow, so it can download the model from the MLflow backend down to my local laptop. The next step, of course, is to tar it up, stuff it in that Scratch bucket, and then invoke the backend to create the VM and put the container in there and create the Conda environment and run the model. So this is going to start, and it's going to tell us that it's waiting for this to go into. Okay, created endpoint configuration, waiting for endpoint to reach in service state. This takes a few minutes, 3-4 minutes. And so it's going to keep doing that. Let me fast forward. It's going to keep doing that. And the deployment operation completed successfully with message. The Sagemaker endpoint was created successfully. I'm quite certain that you can do this in an asynchronous manner, also kick it off and then go back and look at status. But I haven't actually tried it, and this is how I did it, so it works fine. Let me go to the invoke step. Now, in the invoke step, you'll see that I have a small bit of Python code that's going to invoke the API. If you look at this, so the code itself is very simple. Endpoint is xformer. Remember the name that we specified when we created this deployment, that name. I'm opening a client, boto3.client to SageMaker runtime, and I'm invoking the endpoint with the JSON format being panda split, and the body is, of course, two very same strings. This is terrible weather, and this is great weather. Let me go ahead and run this piece of Python code. And so for this invocation, it actually is authenticated with signature v4. So you need AWS credentials for calling the API, and it's all HTTPS encrypted. There we go. So we invoked it, and we got this is terrible weather, labels negative, score is 0.9979, A309, whatever. And so that's fantastic. That it brings us to the end of that demo. Let's go take a look at a couple of things that are relevant to this before I open it up for Q&A. I have two Medium articles. One is called Serve Hugging Face Sentiment Analysis Task Pipeline Using MLflow Serving. That's the first half. That's where we push the model to MLflow. The second article is deploying an MLflow model in SageMaker. Both of these have references to all the details that you know. You can come back to the recording of this as well to take a look at it. This is in the publication InfinStore. You're welcome to go follow that and make sure you get updates. Finally, let's poke around in the MLflow UI. So this is our MLflow. This is our MLflow enterprise MLflow user interface. As you know, you can click on this, and it's going to bring up an experiments and models page. This is actually our free service. So if you want to just get started playing with MLflow, your easiest way to do this is to bring your own bucket, create a bucket, and come by to our website. If you can go to our website, you can click on Quick Start, and MLflow free service instructions are pretty simple, straightforward, and you should be up and running with an enterprise-grade hosted MLflow service within 5 minutes. So I logged the test experiment 2. Now, here's the authorization bit that I talked about, right? I can click on permission here, and maybe I want to have a group called data scientists, and I want to give all data scientists editor roles. I can do add, and maybe delete, modify, that sort of thing. And this is at the experiment level. So let me click on the experiment that I actually ran, and the model is registered here. If you click on the models tab, you have sentiment analysis model. So again, permissions here, you can add for users or groups, and you can set it up for reader or editor or manager permissions. The version 2 is the one that we were experimenting with, and we showed, and again, this is the run ID that we were looking at. So let's go back to the PowerPoint and finish out with a few more thoughts. What are the capabilities that we add to the platform in addition to MLflow's core capabilities and all the enterprise enhancements that I talked about? We also add data versioning. And this is the ability to go back and look at the data, whether it was used for training or inference, and it's essential for scientific correctness. If you have data that changes on you, it doesn't matter if you have the experiment log and the parameters log and the code log, the data is different. So you can never say that I can reproduce this result by running that experiment again. Or, if you have regulatory reasons that say, you need to remove this, and this data and rerun, create a new model for some regulatory reason, you can go back and take a look at that snapshot of data, copy it out, make the modifications that you need, and do a new run. Now you have a new model. The new data is snapshotted. So every time, and maybe you're going to record this as version 12 of your model. And if you go look at version 12, you can click back on the run that produced it, and you can click back at the data that was used for that particular run. Data versioning, critical for completeness of your platform. If you are in any sort of enterprise environment where you're doing serious data science, then this is an essential feature. Our architecture is very, very interesting. We are very proud of it. This is, of course, Jitendra's invention, and his background in distributed computing shines through. We're a completely serverless Lambda and DynamoDB implementation. We do not use MySQL, we do not use VMs, we do not use containers. And the beauty of that is when you have 0 users, your charge is $0. We have about 30 staging environments, and we don't pay anything for most of them. On the other hand, we have customers who are using it so much that they're paying hundreds of thousands of dollars for the use. They have hundreds of users and they're pounding on it. So that's the perfect cloud scalability value, right? You can scale to any number of users and pay exactly for that number of users. We take a look at that particular architecture before I open it up for questions. Here we have data versioning, and this is our data versioning user interface. That's not available in the free service, but if you need to experiment with this, let us know. We have a few more levels of service. We have a SaaS version where you can come in with your AWS account and establish service against instantstore.com's MLflow service, and you can have this capability, data versioning, available there. And of course, if you want enterprise licenses where you install using CloudFormation in your environment, and more than half of our customers are that way, then you get all of these capabilities and more. So this is our architecture. On the left, you have various things like Jupyter Lab, Sagemaker, Studio Notebook. Using it, we log to a serverless Lambda, set of serverless Lambdas, which store their state in DynamoDB. Our UI is HTML and JS that is served out of S3 using CloudFront, and we use Route 53 for all the DNS entries. So here's a high availability aspect of our system. Now, if you look at our system, you can see that the things that could go away are Lambdas and the DynamoDB part of it. The thing that you will note is that Amazon, by default creates 3 availability zones. If you're running Lambdas, they run in 3 availability zones. And the same is true for DynamoDB. It is running in, it's replicated across 3 availability zones. And my reading of various documentation from Amazon indicates that they're pretty resilient to availability zone failure. Again, if there are AWS folks in this call, please clarify. Or disaster recovery is a manual operation. It's a little bit more complicated than high availability. High availability is, zero touch. You can automatically be guaranteed that it will be available. For disaster recovery, if the Lambdas and DynamoDB and the API gateway fronting it disappear, you can use what is called as global tables. Again, this is a DynamoDB capability that's pretty fantastic. We use that to recreate the DynamoDB, the Lambdas, and the CloudFront API gateway in a backup region. Thereby, within 30 minutes, you can have the service up and your data scientists can continue to use their system. Remember, if the MLflow goes away, the data scientists will see exceptions in their day-to-day activity and their work will grind to a halt. So we really need this to be operational. That brings us to the end of the presentation. Here are some useful email addresses. Connect with us on LinkedIn, follow us on Twitter, all the usual things. And let's open it up for questions. You can pick which version you want to roll back to. The question is, in terms of rollback and model management, what does Enterprise MLflow offer differently from the open source version of MLflow? Does it provide serving history? For example, if V10 needs to be rolled back, it is not always the case that we can use V9. So we have a complete log of all the activity that is done on the system. So if you move one model version from production to archive or staging and another one to production, that is recorded. So yes, we do have the capability to give you a history of all the models serving. You can pick any model you want to go back to. You may have model V2 in archived state, put that into production. As part of the transition, it'll ask you, do you want to take the existing production model and put it in archive? Yes. And the best part of this is that it's all read-only, nothing, meaning there is no change to the model itself. You're just transitioning the stage that the model is in. You can always go back to any of those. Is there an approval process when changing model version to different stages? So we've heard this from another customer of ours, and the answer to it is not right now. It is something that's on our roadmap. We'd love to work with you to make that something that can fit a broad range of use cases. But the short answer to your question is we don't have that functionality yet. It's on a roadmap, and we'll be happy to accelerate it if you are interested. Model group, it is user groups. And the question is, does Enterprise MLflow have the concept of model group? The answer to that is we have users who belong to groups, and permissions can be added in any sophisticated manner to groups. So if you go to a model and you say that group data scientist has editor role for that, you can make tag and other changes to that. And you can have interns, the group called interns have read-only access to the model. That also works fine. They can't make changes to that. So you can build a sophisticated permissions model around that, but groups are imported from your Active Directory or OAuth2 or whatever other system, and they are used in our implementation. Correct. Permissions is permissions available only in enterprise? Correct. We have authentication and authorization, and that is only part of our enterprise offering.
So while we wait for a few more questions, for those who are interested in the Yeti Tumbler, email me your work email address and your shipping address. I'll put my email in the chat. And then for all other information about InfinStore, please visit our website and follow us on LinkedIn and Twitter, and I'll put all the links in the chat. And we got a couple more questions.
2 more questions. Any drawback to using MySQL as a backend store? It's a scalability problem. It'll be fine for 3, 4, 5 users, but you have 100 data scientists who come in at 9 a.m. and log in, it's going to fall over so fast you'll be surprised. Because MLflow actually is a pretty intense activity. If you really use MLflow properly, you're logging parameters, you're logging metrics, you're logging a lot of things, and it can overwhelm MySQL very easily. Again, as I mentioned, Jitendra was one of the original authors of HDFS, and that is a name system that can take billions of name entities and petabytes of data. So his design of our DynamoDB-based MLflow is informed by that, and our system scales much better than MySQL. That's one. We're very proud of that, and it's something that, of course, standing on the shoulders of giants, DynamoDB is a wonderful database for this sort of purpose. If used right, it gives you tremendous power. By model group, I meant grouping different models together, like the model ensemble. There is no such concept. And while I'm tempted to say we'll add that to enterprise MLflow, my gut, I haven't thought this through. So I'm just speaking extemporarily. I think that is functionality that may be better done in core MLflow, in open source MLflow. Now we're happy to work with you to contribute that to the core MLflow platform, but I think that's something that the rest of the community can benefit from. So we would want that in core open source. Interesting idea, though. I mean, this is clearly you're a very sophisticated user, and we're happy to interact with you on that. Is it recommended to use Makefile to automate MLflow deployment, or any other suggestions? Here we have an old school Makefile guy. I'm an old school Makefile person too. I love Makefile. Never understood why people invented Maven and whatnot. But I will say this, there are many more sophisticated ways of doing things than Makefile today. MLflow CLI gives you the ability to get the latest version of models and so on. And it's a very easy scripted environment. I would say that when Makefile's value is when something changes, you can do something else, right? You can chain those things together. So yeah, I'm guessing here that you're suggesting you hit make and it figures out there's a new version of the model and I'll push the model to production. Well, that's possible, and I'm sure you can jump through a few hoops to get that done. I think you'll want a little bit more control over your automation. So perhaps if you're a Bash script expert, you can, or even novice, you can do quite a bit more with Bash. If you are a Python programmer, then you can do a lot more with Python also. Makefile wouldn't be my first choice, but there's no real reason why you can't use it. And you will have to augment some of these things with Bash scripts and whatnot. But automation, yes, absolutely. I mean, you should automate these things. You shouldn't be in a position to, if the new model is rolled out, if your MLOps team wants to roll out. See, the interesting thing here is the experiment tracking and the model management is the handoff point, right? Experiments are generally used by data scientists, but when they hand off a model to the DevOps or MLOps staff, that's the transition point. So you do want to be able to automate that and build sophisticated systems for monitoring and around that. We don't have monitoring capabilities in our system, but Sagemaker actually includes some awesome monitoring capabilities. Can we use MLflow with ECS, meaning Elastic Container Service? Absolutely. I mean, MLflow is a really friendly piece of software with other environments. On the input side, on the data scientist side, you can use it with, Jupyter Lab, Sagemaker Notebook, Sagemaker Studio, Google Colab, whatever. On the deployment side, what I demonstrated today is the easiest way to deploy models in the cloud, flat out. I can't think of anything that's as smooth. But if your requirements are to use containers in ECS and you're building your own ensemble software and you're doing something different for your own requirements, absolutely. I mean, it is fairly straightforward. I would suggest, and all of this is open source also, by the way, even the Sagemaker pieces. I like the piece they did where they make a container that's compatible with MLflow 1.23.0 and push it into the cloud and use it. But I suspect if you look at it, you can use that container in your own Elastic Container Service and put that together also. Once again, you may want to really look at SageMaker capabilities before you go with ECS, because a lot of those capabilities are offered at no extra cost. Although I do believe that the ML.x instances cost more than the standard instances. And so that, I'm not going to second guess your reasons for using ECS, but the answer is yes, you can use it with any container management system, including Kubernetes or ECS or whatnot. And if you can use the code that they have to push a compatible container to the cloud and use that container, I think you'll win from that, because when 124.0 of MLflow comes out, you'll have a new ability to get a new container going for your book. But that's how I would do it. If I were going to use ECS, I would take the container that SageMaker creates and use that in my own ECS instance. Fantastic questions, guys. I really like the deep technical involvement. Oh, I should actually mention this one last point. There was a question about MySQL. So the MySQL backend version doesn't have authorization information stored in the database. Neither does it have authentication information. It's basically a single user system. So that's another thing you won't get out of that. Our system actually stores the authentication information in your authentication framework and the authorization information in the database. So if you come in and log in as person X, even if we have a disaster and we locate to a new region, the database comes up, it knows who's got access to what. There's no security leak there. So we'll do a perfect reproduction of your security capabilities.
Yeah, if there's no more questions, thank you all for attending our event. And if you have any other questions, feel free to email us. And yeah, have a great rest of your day. Thank you.
Thank you all.